What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Hi everyone, welcome to Charlotte IoT. I have to apologize for it to be a little bit more chaotic than usual. We had two things happen. Our presenter canceled. He had something else he had to do like 6 hours before this talk. So if you're here to see the Node MCU workshop, then sorry, we'll have to push that some other time. But the positive side is we got awesome Steve Willoughby here to talk about Azure IoT. And I really thank Steve for coming through at the last minute at the request and doing this talk. So yeah, thank you, Steve. Our group is growing like crazy. We're over 1,000 people, 1,132 people, and just exploding. And we're doing some really awesome things. We did a hackathon the other weekend, and Jeremy will talk about that in just a little bit. But just really having fun and doing awesome stuff. This board here is amazing. This is why we're like one of the best groups in town, because we've got so many active people all contributing, doing amazing things. And my name is Dan Thayer. I'm president of Charlotte IoT. Graham Hardy, he couldn't be here, but he is our facilities person, and he helps with a lot of things. He's also the one who orders the food, and so like we're lucky that we got food this time because I had to order it. And Graham's amazing. And Rob, our hands-on lab coordinator, he just like does totally like one-of-a-kind, awesome labs. And he's organizing something for the Maker Faire that's going to be like really great for beginner people to learn how to build things with circuits, and hopefully it'll be a connected solution, but maybe you can talk about that when we get to the Maker Faire slide. And Joseph, he's our streaming media awesomeness person, and Joseph also does like random things constantly to help out the group, from making signs to doing marketing to helping out in hackathons, and just really appreciate everything, Joseph. And Mike Lisenki, he is our awesome swag coordinator, and he hooked us up with Hackster, and he's the reason we have this train of swag coming in every month. And Mike is another one of those who just does things behind the scenes, and all this magic stuff starts happening. Christoph, I don't think he's here because he's at some conference, but he's coordinating big events. He's going to be coordinating the Maker Faire, our activities there this year, and any other big events we do. Like Glenn, he's our social media wizard, and if you post on Instagram or Facebook, we actually have some prizes. So we've got 2 Docent ESP8266 boards that you connect into the Docent platform and do some amazing, awesome stuff. We did a lab on it not that long ago. But if you go to our Instagram or our Facebook and you say some like awesome, amazing things, then we'll put you in for the raffle. If you're not polite, you aren't in for the raffle. So. And then Jeremy, he's our latest member, and he is helping with our civic hackathons, and we'll talk about that in just a little bit. But I'm so stoked with everything that is going on with that. So we have our YouTube channel, and Joseph, he's like the wizard who does our YouTube streaming, and he does this not just for us, but for other people too. And he does commercials, and like if you have a product and need an intro, he's really good at all this stuff. So you should check out how awesome our video quality is, and it's like multiple cameras doing really cool things, and you should talk to him about doing something for your business or whatever you got going on, because he's like amazing with this stuff. Oh yeah, I forgot to say what our channel is. It's charlotteiot.com, so YouTube/CharlotteIoT. And what's also really good is when you see something that Steve says that's amazing tonight, but you can't remember it because he like made it a little too confusing. No, sorry. You go to the video and you can watch it as many times as you want. It's awesome. And we have our Slack and our Twitter. And Mike is like awesome. If you on Meetup, when you register, if you put in your email account, then he'll give you an invite to Slack. And that's really that, or you have to talk to someone to get an invite to Slack. Any of our members can invite you, but Mike's the reason why everyone gets invited to Slack, so thank you for that. And Slack is pretty cool too. It's lots of channels to talk to about what's going on, like the Civic Hackathon and other things. And, oh yeah, back to Slack. If you're doing a project and you have questions, there's no better place in our community than Slack than to go post some questions, because there's all these like awesome wizards here who love to build and help and ask questions to, and just post it on Slack, and all of a sudden you'll get like 10 responses really fast. So our sponsors tonight, first and foremost, Logical Advantage. That's my company. I'll talk about that in just a little bit. Hackster.io is completely amazing. And they give us like tons of swag, and they also give us $200 every month to spend on whatever we want. So we buy even more swag. We get things for hackathons, we get things for the Maker Faire, and just like just really amazing things. They're an awesome partner of ours. And SnapAV, they're our facility here. They are an IoT company here in town. They've got hundreds of thousands of IoT devices in their cloud. And they do a lot of AngularJS and Node.js type stuff. And they're always hiring people. And if you guys do that sort of thing, then I would talk to Graham. Probably the easiest way to get up with him is on Meetup. And just send him a message. Hackster, they give us the $200. And it's also really nice to send them love. That's their Twitter handle. Just keep the swag train coming and thank them for giving us cool stuff. Mike, have there been new stuff we got from Hackster this month, or is it some of the same of the old stuff? Or
if they ship something this month.
The amazing thing with Hackster is it just flows, and it just is like amazing. And so yeah, we get tons of really cool things.
So I think they might have taken a summer break.
Yeah. That's cool, because we've got a lot of talks to talk about, so we'll save up on the swag when it comes, and we'll do lots of hackathons and things like that with it. This is for Logical Advantage. That's my company I'm co-founder of, and we've been in business for just over 14 years, and we do epic things. We like to do the hard enterprise projects, and I'm going to talk about this project because Steve Willoughby is going to talk a lot about it during his talk. So his whole presentation will be like a commercial on how Logical Advantage rocks and is totally amazing awesomeness. So,
oh, so that's what it is.
Yeah. We've done a lot of other IoT projects in the past. Here's a smart city one where we're tracking millions of carts in hundreds of cities and using RFID and barcode. Steve worked on that project too. And we've done a lot of other really cool projects. I won't even talk about them because Steve will talk about some awesomeness stuff. Civic Hackathon. Jeremy, can you please update us on the awesomeness we did last weekend?
Yeah, so last weekend we, Lending Tree, where I work, was great enough to lend us some space. And we just, we had about 25, 30 people there. And it was a great, just a great learning experience for some. And others were there, and I mean, it was just a day of working and getting things done. I want to thank Mark. Mark was great on his team. Dan obviously ran an amazing team too. Dan's like,
the 15-year-old girl Abigail was awesome. She ran the team.
I know, right? And she's in their Eagle, and she's in Eagle, and she's doing PC board design.
What I'm like super stoked with too is we made one PCB during the meeting, but we hadn't even started the second circuit design, and her school just started, and she's like 14. She's like, I can do this after school. So the week after school, she finished the PCB design and emailed it in. So.
And that's an amazing part of these hackathons. We did get to the point where we could put the Echo and the Amazon Fire and the Harmony Hub together to put together the ability for Sean to change channels, controls TV, and do all of that with his voice. And that was his #1 request. So it's really a lot of fun to be able to say, you know, we've given somebody, you know, something they really need, something that makes their caretaker's life a little bit easier, and something that really gives them freedom in their life. We're working on some PC board designs to do automated controls. We had Jonathan, who is another quadriplegic, come, a friend of one of the staff members there at Lending Tree, and provide us some amazing feedback on what we could do. And you know, I've got a lot of people at Lending Tree really excited, so I'm hoping we can continue to use our facility and continue to do this. There's a lot of things we'd like to put out there and document, you know, and maybe do some training around the area for different groups to help them understand this technology. I've got a lot of things that really I would like to do and like to see this group do just for the community. And it's so rewarding to do one of these events. At the end of the day, you're on cloud 9. And I invite anybody who is free to come to our next one. We'll get that put together sometime, and you know, and join us. It's something that's just completely amazing. So.
Hey, raise your hand if you participated in one of the 2 civic hackathons, because look at this. This is like amazing. You guys are awesome people, and let's give you guys a round of applause. Thank you for your help. And thank you too, Jeremy, for your leadership. The next big thing coming up is the Charlotte Maker Faire, and last year we had 14 volunteers, and we did it really big. This year we hope to do it just as big. We hope to have a booth with 3 tables on it with all of our IoT goodness stuff, and then another table to the side where we can do a workshop. And I'm not sure, Christoph is organizing it, and hopefully he can organize a workshop that's Halloween themed with LEDs and things like that, pumpkins that light up. But he'll have to update us next month if he can pull it off. Yes?
Will there be pumpkins that breathe fire too?
Not at Discovery Place. You can come to my house anytime for a fire-breathing pumpkin. Yeah. And also at Discovery Place on September 19th, I think that's a Tuesday, they're having a night for adult makers. And I haven't seen the new space at Discovery Place, but I hear it's pretty awesome. And it's made for makers, and they also want to do a kickoff for the Maker Faire, and they asked me if I could speak at it, but that was months ago, and I missed the email. And I just replied back over the weekend saying, yeah, I can. So if they haven't filled that, I'll be speaking at that. I don't know if they have or not yet, but it should be a fun night to come to. And we've got some really cool meetings coming, and something that I think we can use, like what's better than speech control? How about mind control? And this might be something we can use with our Civic Hackathon. I'm not quite sure. But is Brath, is that how you pronounce it? I'm not even sure if that's how you pronounce his name. But, are you here? Is he here? He is going to, he's got this headgear that posts data into Azure, and he analyzes the data to figure out what you're trying to control, and then we'll send a command to Raspberry Pi or something and turn a light on. So I think it'll be really fun to do mind control and not even have to speak. That's one thing I hate about Alexa is everyone knows what I'm getting it to do. And if people don't know, it's just more of a surprise.
Dan, do we know what kind of hardware this is going to talk about?
No, I can see if I can get him to post it on our site. Okay. But he put a picture of it. I don't know if you can tell from the picture what that is.
If he has anything that can float rocks.
Yeah, floating rocks. Hovercraft. Yeah. That would be sweet. And then in November, we're going to do lightning talks, and we've got 3 of them planned. And the first one is from David Simmons. He's going to come in town from Raleigh, and he's going to talk about InfluxDB. And that's a IoT. I don't even know much about it, but it's a database made for IoT, and I assume it's really scalable and really cool. Can't wait to hear about that. Rob, please, he's going to have us vote on his talks because he's got like a whole bunch of them queued up. Which ones?
So Dan and I were talking before the meeting. Based on who's here, you can kind of raise your hands and I'll let him pick one. But basically, the first talk I have can talk about using Microsoft Cortana, talking to the Raspberry Pi to do facial recognition and image recognition. And the second one I have is one that I actually presented for a gaming development meetup, but it was using the HoloLens to interact with objects in your game to control something in real life. So again, that kind of uses the IoT hubs and a handful of hardware devices and stuff like that. So we can either do a Cortana demonstration or a HoloLens demonstration.
So raise your hand if you want to see Cortana facial recognition. And then if you want to see HoloLens. Some people voted twice, but you guys are the cool people. I want to see HoloLens too, and I'll put 2 hands up. So I vote for HoloLens, and thank you, Rob. That sounds really good. And Jeremy's, he's built something that we're using in our Civic Hackathon that bridges the Amazon Echo Cloud with the particle photon. And you want to?
Yeah, it's, so we basically abstracted away everything to allow you to use an Alexa skill and a library in particle photon. And you're able to implement Amazon home automation skills like turn on a light, change color of the light, lock a door. 5 lines of code, no joke. We've abstracted it away so much that it's become kind of my thing to do now at the house, just automate everything, right? But seriously, it's an amazing little tool that we can use, especially for the Civic Hackathon stuff. And it's really cool. Just really simplifies everything.
So yeah, you guys won't want to miss either of those 2 meetings. And then you won't want to miss our December meeting also, where the Chief Enterprise Architect from Hewlett-Packard is flying in town. Do you remember where he's from, Mike?
Some West Coast place.
Somewhere West Coast, San Francisco, or some really cool place. But he's the architect of their big data platform, and so we know he's going to have some like really exciting stuff to talk to us about. Yes, Mike?
So there's actually HPE is like an IBM. They're now a parent company of a whole bunch of little companies. And so you have to look up each little company does something completely different, and they don't know about each other, because I've got a friend in Nimble who got purchased by HPE, and I asked him about is it Vertica?
Yeah.
Anyways,
yeah.
And he knew absolutely nothing about them or their business. And he said that they knew nothing about him and his business. They're all
big companies, yeah.
Completely compartmentalized.
Yeah. So, but it'll be good to hear from like a big company's perspective on big data and how we can use some of their tools. And he said he wouldn't keep it focused on just their tools. He's going to make it like awesome in other ways as well. Yeah.
Is there anybody else in the room that works for HPE as a subsidiary? Because there's like Fortia, and they were speaking at the DEFCON 911 and the OWASP meeting. They're into security and stuff. So it's interesting, all of a sudden HPE became on my radar like a couple of weeks ago.
Yeah, nice. Yeah, I'm super stoked. They weren't really on my radar, but now they are, and a big company like them, they've got to have really awesome stuff. Steve Willoughby, thank you very much for presenting tonight. I could only find a picture of the back of his head. It wasn't because that's like the best view of him. But he's a tech lead for Logical Advantage. You've been with us for a decade or more. How many years?
11
12
years,
years,
1 week, 2 days, and about 14 hours.
Nice. And it's been like awesome for both of us the whole time. So yeah, he's been really awesome for our projects and just helped us a lot through the years. Thank you, Steve.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Thanks everybody for coming tonight. I think it's a pretty interesting topic, the Azure IoT Hub stuff, and something we've done a pretty major project with at Logical Advantage. So we'll go through some of the specifics of how that worked, and sort of go through I think just general information about IoT Hub. There's a lot about it, but I think you'll find out it's not a huge part of your effort if you use it. Is anybody using IoT Hub in production right now? Okay, anybody else? Is anybody using Event Hub in production? Okay, all right. So they're very similar. We'll go over some of the differences between those. But so we'll go over the history a little bit, and we'll talk about, hang on a minute, that's the wrong presentation. Is there anybody that would like to see a Git presentation instead? If so, I've got one of those too. Here we go. Let's try this. That looks more like it. Okay, we'll start. We're going to talk a little bit about the IoT market and what this IoT Hub thing is. How do you talk to it? Will it talk back to you? It's tough to get a lot of this in an hour, but we're going to try. We'll get as much as we can here. I had a message routing example in the original presentation, and I can't find it. I actually just got the call from Dan this afternoon about 3, and I was at the doctor's office uptown, and so I had to go back to Mint Hill to get, so it's been one of those days. But I can still talk about the routing a little bit and show you some of the setup. Then we got the the Industry 4.0 piece that we did for a company called Service Thread in Laurinburg, North Carolina. We've done a phase 1. We're going to launch into a phase 2 pretty shortly. And I think it's one of those things that in concept is pretty simple, but when you begin to put all this together, it's amazing how many details there are to sweat when you're putting one of these things actually out into production. So we'll talk about some of that too. Just a quick blurb on the growth prediction here. This is something that Gartner, I think I got this from Forbes, they're talking about by the time it hits, is it 2020 or something like that, it's going to be up to, it's about $70 billion today in this market, and it's supposed to be like 260 or 270 by 2020. I mean, it's just crazy, you know, and then the more people see it, the more they like it, the more ideas they have, and the faster it grows. So it's definitely a market that we're excited to be into. So IoT Hub. So obviously it's an Azure cloud service. You know, what does Microsoft have that's not an Azure cloud service, I guess, these days? But obviously this is. There's not a simulation environment, so in other words, you can't run something locally to do this thing. You've got to do it up in the cloud, or at least there's nothing up. There's something on GitHub, but I didn't even want to go there. So you got to have a cloud account to use it. It's fairly new. I think it came out in February of last year, so it's not been out there terribly long, and we'll go over the differences between it and Event Hub. But certainly one thing is that it will receive messages from devices, and it will also send messages back to devices, which is a pretty significant difference between it and Event Hub for one. And once you've got, that's why I say this is kind of like an enabler piece in the whole IoT scheme. So once you get devices registered and begin to receive the data or send data back to the devices, the possibilities are almost endless at that point. Because you got stream analytics, you got service bus stuff, you got function apps, you got, you know, it's just unbelievable what you can do with the data once you've got it streaming in. So IoT Hub is really the piece that kind of like makes that happen. Yeah, a very small part of your implementation. So here's a diagram I found somewhere. I liked it. Windows IT Pro. Kind of sort of shows that it's so early in the process. It shows that there's your C# simulator as your device. So this is pretty early on. But it sort of illustrates, you get the stuff in, the information in, and you can take it so many different places and do so many different things with it that it just boggles the imagination. Features, you can do per device authentication, so you register your devices. Each one has a particular ID and some security pieces that go with that. You can route to other Azure services using declarative rules. They're pretty easy to set up. That was part of my code example. We'll still talk about it though. There's a pretty decent portal dashboard for monitoring devices. I just look at that dashboard and I think, well, what if I had 1,000 devices out there and I'm looking at this thing? Like, I don't know. It does have query capability built in though, so that's helpful. There are a lot of dev libraries for different languages, and I'm sure more and more are going to show up. Obviously, we did the project that we did in C#. We're pretty much mostly in Microsoft shop. And they claim that they can handle millions of devices and sending millions of messages per second. They claim to have tested this. And if you go that route, it'll cost you.
Quick question: what kind of authentication is available from the device end to prevent spoofing or?
Yeah, as I recall, I think it's just. Yeah. Hey, oh, I'm sorry. Sorry about that. Do it on this side. It's certainly HTTPS. It's across secure transport. The devices, everything is. They all have their own security keys and things like that. But other than that, that's pretty much it, as I recall.
Thank
Okay, some of the numbers that I got just for I thought were kind of interesting. You can a message that's received on IoT Hub, you can retain it for up to 7 days. You can also each message can be up to 256K. You can batch messages into 256K blocks, which I thought was kind of interesting. Haven't tried that. Maximum amount of device to cloud messages within one of those batches is 500. And but then going the other way, it sort of chokes it down a little bit more. So if you want to send something back to a device, you got a max message of 64K. And the time to live is 2 days for cloud to device messages. And there's all these specs. All this stuff is spec'd out online. If you get a copy of the slide deck, the link to this particular set of criteria or parameters is on the slide.
So Steve, it must sit on top of Event Hub then.
You know,
those numbers are very similar.
They are very similar. Yeah, I don't know. I haven't read that specifically, but you got to be pretty suspicious about that, right? Why would they duplicate that same sort of technology when they could just add on to it? The pricing is really, I thought the pricing was fascinating. So you've got, with IoT Hub, you've got 4 different levels or editions, and one is free, which is pretty popular. Then you've got these other levels that the way they charge is not real intuitive. So you look at this, and you've got for you can do 8,000 messages on the free level each day. But then there's this message meter size. All right, so the message meter size is a half K. So what that means, though, that what you actually get charged for or counted as a message is the meter size. So let's say, for example, that you've got one message that's 8K for the free level. That's actually counted as 16 messages. All right. So, and that's how you would get charged. If you're at S1, S2, and so on, where they got the 4K meter size, then that 8K message would be actually 2 messages. So why they split it up like that, I don't know. But it's a pretty clever way to get more money, I guess. I don't know. You got to read the fine print on that one. So I talked a little bit about some of the differences between the IoT Hub and the Event Hub. Certainly the fact that the IoT Hub will allow communication in both directions, to and from devices. The state informations, device twins, which I haven't really gotten into at all. Have you looked at device twins? Is that a functionality that you've investigated at all?
So it just released back in June, I believe. So it's relatively new. There's some cool stuff you can do with it, but I haven't fully investigated all that it can do.
It's kind of like caching the state, the last state that it knows of each of the devices, I think, is so that's available, and that's not an Event Hub. Protocols are pretty similar. MQTT, WebSockets, it's the usual list, a little bit more, I guess, there on the IoT Hub side. Again, you do have the security where you can control per device. So if you got a device that's acting up or suspicious or something like that, you can just disable it. Scalability, they really say that the Event Hub will handle a few 100,000 messages per day or something, whereas IoT Hub will do millions and millions. I forget the exact numbers on that. SDKs, I mentioned before, there are a lot of device SDKs out there for both Event Hub and IoT Hub. Routing the multiple endpoints is kind of interesting. And that was part of the example I had. You can set up these rules that will say that if your message has a property and that property has this value, then you can route it to this particular endpoint. So that you can have things that are listening to that endpoint and other things that are listening to other endpoints. So if you've got something like a warning that goes off or some disaster or failure, you can go to another endpoint, or it can go to multiple endpoints. So there's a lot of configurability there as far as the messaging goes and the routing. So yeah, that was my example. Let's see, what can I do with this example? So what I did was I had two custom endpoints. I'll show you this in the cloud. So I had a normal endpoint and a warning endpoint, and so each one of these endpoints you got to have a service bus queue for. So I had two routes. So there's a normal route, which would route to the normal endpoint, and then a warning route. And so those routes will have some filtering logic. And it's kind of like the where clause in a SQL statement, sort of. I'll show you that. So then what I had in the code that I couldn't find was I had a property that you can add to the message. You can add properties ad hoc to these messages, and with magic strings. And so if the value was true, it would go to this endpoint, and if it was false, it would go to the normal endpoint. So let me switch over to that actually and see if we can look at that a little bit here. So here are so moving over to that screen. So what we've got here, let me also change this. Let me duplicate here real quick. Okay. So this particular queue is the one that's going to enable the things that come in that don't have the warning property set to true. This will be the ones the queue for the warning property set to true. So, but the real activity is going on up here in the event hub. So go into this guy, and then what you've got are the endpoints. So again, here are the two endpoints that are set up to go along with those particular message or bus queues. So we've got the warning endpoint, and we've got the normal endpoint. And then the routes, this is what I was talking about as far as sort of like a where clause logic in a SQL statement. So for the normal route, if the warning is true or the warning is false, it took everything. But if the warning was true, then it just went to the warning route. So things that listen to that particular endpoint, the warning endpoint would then get those messages and those messages only. So you can imagine that there's a lot of flexibility in what you can do here. You can set up a lot of different endpoints and routes too.
Are those properties in the message themselves, or are they some sort of filtering that you do based on where it's coming from or content?
Well, that's where I wish I had the code. You actually can just like add a property on the fly. It's just a list that's exposed as the property is called properties, as I recall, and it's just a generic list. So you can add things to that. It's a list of name strings, I recall. So then you can add what looks like properties to it, name value pairs. And that's how you add these things, these properties to this, that it will evaluate here in this route.
So you can actually process the message and then apply some, based on whatever the analysis of the message is, you can apply the properties on top of that.
Exactly, yeah, and it can go anywhere from there. So yeah, exactly. Yeah.
I think that's outside the message body though, isn't it? I mean, the body
is
bigger.
Yeah.
Bigger
So, yeah.
construct.
Yeah.
So you're basically pulling headers up so you can evaluate before you deserialize the entire body.
Yeah.
Okay.
Yeah, that's exactly right. It's a property of the message, and then there's the internal part of the message.
Right.
Yep. All right. Without my glasses, it's really hard to find anything. Okay, yeah. So we looked at the portal setup. I wish I had the source code. It's surprising how little source code it takes to do this kind of thing. It really is. So you just set up like a couple of client objects. Yeah.
Now, I think I asked you this when you presented at Logical Advantage.
Yeah.
But you've done all your coding with this in the context of either C# or F# or some Microsoft.NET language, right?
Or some like wizardy plug and play thing through like the Photon portal, for example.
Okay.
Mm-hmm.
The Photon was generating data, so it was pushing stuff out, and probably did less of the back-end logistics of and decomposing the message.
Right.
Although, was there libraries for the Photon that just plugged in that Microsoft gave you to put your properties into the message stream?
No.
So you had to construct the data for that on the Arduino side or the Photon side?
On the Photon side, yeah. Which is pretty straightforward, you know. It's just a little C code. But so then the way that works, we'll get into that whole service thread functionality. The way that works is that the Photon has its own cloud, so you send the messages up to the Photon cloud, and it has a synchronization that you set up. It's very simple to do. And then it just relays that over to the IoT Hub. And it recognizes your device ID and that type of thing, and it just sort of passes it along, passes it through. That was the annoying thing, though, is that at that time, at least, we had to go through their cloud. And their cloud did go down one day. You know, it's a free cloud. You know, you don't expect a whole lot, I guess. So we hope to get beyond that when we move on. I think
they actually have paid cloud too.
What's that?
They have the paid cloud too.
All right. It'd still be nice to get away from their cloud altogether.
Did you have to put code in the Photon cloud?
No.
Okay.
It's literally, it's like you fill out 4 text boxes or something like that, and then it just relays the message directly across. And then what we did with the messages after they were received in the IoT Hub is we just used the Function App, and all the messages went to the Function App. We made a decision in C# code in the Function App. We'll get into that too. Like right now. So service thread, what service thread does, as you can probably guess by that mock-up over there, is they make custom thread. So like for fire hose coatings and for anything that needs something that's not just thread that you make clothes out of. So they make industrial thread, I guess you'd say. So then each one of these winders that they've got how many? 300 winders? Dan, is that what it is?
No, pushing 4,000.
Winders? Or spindles?
You're talking about spindles. Winders, somewhere around 300.
300, yeah. So each one of them has a number of different spindles on it. And the interesting thing is that each spindle can be making a different product. So they're really concerned about like downtime. You know. So what one pattern they have is they've got a lady that will be stocking up a machine over here, getting it ready for its spindles to go. And then meantime, this other machine she's responsible for, the spindles began to wind down and stop. They're done with their job. So she's still finishing up over here. This machine's just kind of sitting over here, but it could be making products. So one thing they want to figure out is, well, just where are the areas where we have the most downtime, and what can we do to provision these with people or whatever we need to do to mix the products up so that we get better uptime on these spindles. And amongst those 300 or so machines, they get 4,000 spindles. And so that's the thrust of this, is to monitor these spindles and see when they're up and when they're not. So spindle downtime equals bad. So on the first machines we did, which were older machines, it's kind of fascinating in this business. Some of these machines were from like the 20s, I think, originally.
World War II era.
World War II era. And then as time has gone on, they've put like controllers on them and some electronics and stuff like that for feedback. And one of the things that they did in this case is as the spindle runs around, there's a little metal button on a plate that runs around. So it's being watched by an inductive proximity switch. So that's how you know it's active. So that was going into the controller, and they use Siemens controllers. So one of the key factors that we had in mind was we didn't want to disrupt anything, right? We wanted to read from the same proximity switches, not add anything, but we also didn't want to interrupt or change the voltage or whatever the signal that was going to the controller. So that's where Dan came in with the idea for the photon. And so it ended up working out like it was unbelievable. It worked the first time we tried it. I still can't believe that. So the proximity switches are sending these signals to the PLCs, and there could be 50 spindles on one machine, something like that, 48 or something like that. So all we really needed was a state of each spindle once per minute. So that made it easy. We didn't need the RPMs or anything like that. It was just once a minute we would send a message up that would have for however many spindles this particular controller was watching, which could be up to 16 with the configuration we have originally. What was the state? Did they do anything in that last minute? So we would just send a real small message up, and then this would go into Photon's cloud over to IoT Hub, then into this function app that would then make a store procedure call into a SQL database and split that up into individual spindles and machines and times and all that, so they could report off of that data. So since we used the Azure SQL, and it worked out like a charm. It was pretty. That part was pretty easy. The setup was pretty cool too. So we packaged this in a way that, for sure, Service Thread didn't want us to have to come in to install a new one. So it's like, okay, it's time to do this on another machine. They didn't want us there, right? And you can't blame them for that. So we put together, I think, enough documentation and made this piece of equipment simple enough to where their maintenance guys can put these on and get them started. And that's including the software side of it. There's also a handheld app for software setup of each controller.
So, question.
Yeah.
How did you address the individual spindles? Are they different I/O ports on the photon board, or? Mm-hmm. So that's part of the installation. When you set one of these up, somebody just manually says spindle A and whatever their coordinate system is.
Yeah.
This pin, et cetera,
the PLC has like a terminal strip, and all the proximity sensors are going into the terminal strip, and then those have another in the terminal strip going into the PLC. So we just wired into the same terminal strip that all the prox sensors were wired into.
Right, but somebody when you first install it, somebody has to manually input.
Yeah,
pin.
So their maintenance guy has to.
Actually, there's a pure human element there. And we considered having them actually map them originally. But then we thought, well, we can surely instruct around that, because that was going to complicate the setup quite a bit.
And that was really the question, is some things don't lend themselves to automation.
Yeah, right.
And a wire is one of those things.
Exactly, yeah, exactly. So what they do is they've just got to wire them in order. You know, they can tell what order they come into this terminal strip, and then they wire it onto this, onto our device. And then you'll see what I mean in a minute. We got some pictures. And but yeah, there is a human element there, so, which is always a weak point. Hmm?
The person who sets up a new, I guess the machine that holds the spindles, they connect all the wires up at once, or can they put spindles on incrementally? And when they do that setup, do they have feedback? Does your system in real time through maybe a mobile device give them access to, yes, the spindle is running, it's not running?
Yeah, it's as far as having to hook them all up at once, no, they don't have to.
Okay.
There's a handheld app that what we do is when one of these fires up, it goes into what we call setup mode. And so setup mode sends a message up, goes over, and if it doesn't have enough information to run, then it registers itself with a color in a particular table. So then the guy opens the handheld app, it's a web app, and says, oh, okay, that's this particular one should be purple. So he looks at the light on the photon and says, oh, okay, that's the one I mean to work with right now.
So you use the RGB light
Yeah.
on the photon
Actually
to
on the
color
photon.
a certain light.
Right. Yeah, and you gotta watch it though, because sometimes the colors don't look like colors. It's just like, you know, you just got like two little points of light. You know, it's something. It needs a diffuser real bad. But yeah, that's exactly what we did. And so as far as having to set them all up at once, they don't have to. One thing that they do is they give it a range of spindles that are on the machine that will be hooked up and working. So they can say, okay, we know from a machine table and database how many spindles a machine has. One photon will only handle, with the new PCB, 18 spindles, right? Some of these can have 48 or something like that, so they'll require multiples. So they put in, you know, it's going to start with 1 and end with this one, and then the next one's going to start at 19, go to, you know, whatever, 37 or whatever. And so that's how they register each proximity sensor with each input on the photon. So some of the challenges we had there is that, and this is, you know, again, credit to Dan. Dan figured out the right pieces to use here, because they had, you know, one of the things that was originally thought of was, well, why don't we just work with their PLCs, right? This is industry standard stuff, and it's like, wow, well, that's a bad one. There's all these different models of PLCs. You got to learn, you know, they have different programming environments and things like that. One wrong move, you know, what if you throw a machine in the wrong cycle and it breaks something or something? You know, oh God, no. So. Yeah, and the PLCs, at least the Siemens ones that they have, they don't talk to the network without an RJ45 cable and, you know, or a cell card, and it was really awkward. So we thought about, well, what about some black box? But you still got the PLC integration issues, and so then we came up with, or Dan did, with the idea of a separate microcontroller that just connects to the proximity switches, and you know, there were still questions to be answered with that. So what if it divided the voltage or dropped the voltage, and then the PLC couldn't read it correctly or reliably, or how do you power the microcontroller, and, you know, on and on. So there's a lot of how much cost would it add, and then, you know, what are we going to do? Just what is the right decision? We went with the photon, and it just worked. So it turned out it didn't interfere with the signal at all. These things have just been rock steady since we put them in. And like I say, with the exception of one day that the particle cloud disappeared for like, I don't know, 4 or 5 hours, it's been working really well for us.
How long do you expect the photon to last?
That's a darn good question. We have no idea. No idea at all.
So we made them to be disposable.
Yeah.
So if it doesn't work, you just throw it away. Put in a new board and wire it back up.
And that's part of the instructions for the installer too, is that if it goes down, then first you try this, like a reset, then you try this. If that doesn't work, just unplug it, put a new one in. And there's a way you can provision these things automatically. So yeah, that was the idea. They're like, what, 19 bucks a piece, I think.
Yeah, 18 bucks.
Yeah.
Unless you're Jeremy, he gets them for like 12 bucks or something.
It's all in the base
yeah. So Dan picked the photon. It had the Wi-Fi built in, up to 18 digital inputs or analog input or output. Programmable in C, less than 20 bucks. The things in there are really small. There's a good breakout board available for them. But we had to jump through some hoops, right? Then we had to package it. It's one thing to breadboard, you know, we had it in that state right there. Everything worked great, right? You had the one little pickup on there and you're spinning it around, and it's like, oh, this is a piece of cake. So then we started thinking, well, wait a minute. So we're not using interrupts in the programming on this. Is it really going to keep up? These spindles can go pretty fast here, right? So you hook up 18 of them and they're going at a couple thousand RPMs, even though the radius is pretty small. Is it really going to keep up? So we ended up converting that thing to having four pickups on it, and using essentially the same proxies as they had, the same specs, and spinning the thing with a drill at 800 RPM. And, you know, so it started out with this beautiful little thing I made. It was oak, and I even put like Danish oil on it. You know, it was all pretty and everything. And the next thing you know, it's like all hacked up, and Dan thought it was even prettier hacked up with all the extra inputs on it. But so that's how we did the final testing to make sure it would keep up, and it has. So, but that was not the only kind of issue that we ran into. Prototyping took a lot of effort. We needed opto-isolators because there's a difference. There were 24-volt controllers, inputs or outputs rather, or proximity switch outputs, and the photon won't handle that. So we found opto-isolator boards. That's why we were limited to 16 of the 18 inputs, is because these guys only had 8 each. And we sure were glad when that worked, because they came from China and it took a month to get them. So, but it worked out pretty well for us. Yeah, the setup and run workflow. It was, get into some of that here too. So we get into the mounting and everything. So, like I say, here's the first prototype. See, took a picture of it. It's all so pretty there. The lighting's kind of like mood lighting there and everything. Next thing you know, it's looking like this, right? It's got it's hacked up a bit. And there's a little spindle we could drive with the drill right there in the middle. So, long story short, it just worked. And this is what it ended up looking like inside the cabinet. So that's actually the electronic cabinet for one of the winders. And you can see the bottom. You mentioned, you had a question before about can the guy tell whether or not he's actually got a good connection. And you can tell by whether or not the light on the opto-isolator board comes on if you just rotate the spindle by hand a little bit. So you can tell that. And you can also tell if you got them hooked up in the right order that way too, because you can just go right down the line with them and see which light lights up. So that's what it worked out to look like. The top was a breakout board we got from Control Everything, and it was actually more expensive than the controller was. And the opto-isolator boards were $9 a piece, I think, something like that.
$7.50.
Yeah, it just took forever to get them. So obviously we don't want to keep it like that. Oh, and this is this is the rack that Dan was talking about, where all the inputs from the proximity switches come into. So we like tapped into that, and that's the Siemens controller. They use logos. So that was it, and that's what it took to get it in there. It all fit. We powered it with just a USB cable. We just plugged in we had an outlet inside the box. We just plugged the USB adapter in there, and it just all came together. And the first time we ran the thing, it just worked. It was unbelievable. Went all the way through I was like, no, this can't be right.
That was the one that I wired.
Sure, yeah.
So is that box already environmentally protected, or is there any concern about being in an industrial space with an open board like that?
It was yeah. It's a regular electron. Normally they keep them locked. So it's a normal electrical panel like you'd see on any machine tool. And so they have them shut and they have them locked. So it was as protected as anything else that was inside that, or as safe as anything else that was inside the cabinet. So, but yeah, it was pretty cool. I got a video somewhere you can see. As fast as it goes, you can still see the little lights on the opto-isolator flash, which is like me and Dan, it was like we were like giggling like schoolgirls at that point. So let's see what else we got here. So yeah, this is kind of the whole flow I was talking about earlier. So it's you got the photon, proximity switch on the winder. When it initially starts up, it sends out what I call a setup request, and it tries to find out from data in the database whether or not it's been properly, completely configured. If it is, it just goes into run mode. If not, then it registers a color, and then it's expected for setup. So then from there, it goes into this, into the IoT Hub and into the Function App, which is the place where most of the code lives. It receives the stuff, it parses the strings from the messages that come in, and that kind of stuff. Then we got the handheld app that allows the user to see which ones need set up and that kind of thing too. So, and since we did all this, there's been, I don't know how many different reports Carolyn has done, but she's, I know, been pretty active in writing reports, because you know how it goes, somebody gets this data now, and they're like, okay, well, I want this report. And I thought, oh, wow, that's pretty good. I want these 7 reports, too. And yeah. So it's really sparked their imagination. So now we're adding...
So on the spindle activity data consumer policy, I guess, was there already a logic available from a decision hierarchy standpoint to say, okay, out of all these spindles that are down, I want this one to go up first based on whatever the value of that spindle is? Was there already logic built into that PLC to do some kind of position hierarchy?
No, it just spins up, and we monitor the state change. Basically, is the way that we make sure that we know whether or not it's been active. As far as the order of startup, we didn't have any business requirement for either controlling that or capturing that. So the message that it sends up is literally just a string, comma separated string that's got either a 1 or a 0 for each one of the spindles that's connected to it. And 1 means it was active in the last minute, and 0 means it wasn't. So there's the ID of the device and all that it needs in the database to identify it as the one that's on this machine. So
you're sending up messages every minute? Is that kind of
just once a minute? Yeah. Yeah. Yeah, without interrupts or anything, it handled the speed without having to resort to interrupt program.
So you've used the term function app several times. Is that really just where your code lives and a function app is the terminology for the IoT Hub to route to that endpoint? Yeah,
so you can have Microsoft calls them function apps. And they are actually little applications, and you can even get to the folder structure on the virtual machine if you need to, haven't needed to. So all this stuff, of course, lives on VMs. It's not your VM, but Microsoft puts them on VMs. And so it's an application. You can write as many functions as you need to. It's got some standard, like interfaced parameters that you have to have in these functions. And then you can create them for like an event hub listener. In this case, it was an IoT hub listener. And just a little bit of configuration. It's just C# program. Probably the worst programming environment I've ever used for this kind of stuff. I literally had to resort to setting stuff up locally, like with a console app, the fake messages, and then do the coding there, and then copy and paste it up there. Because it's an awful programming environment. And that's what they call it, function apps.
Equivalent to Amazon Lambda, serverless functions.
Right. Yep.
I think they've just released support for Visual Studio 2017 building function apps.
Oh, did they?
So you don't have to do that copy and paste thing
Oh,
anymore.
okay. All right. That will be definitely a pleasure. We got phase 2 coming up, and I wasn't looking forward to that part of it.
So yeah, I really think function apps are going to change the way we do computing in Lambda and those types of things. You think a little bit differently. You don't have to worry about servers where it's going to be running. You just write a function that does some work, and you invoke your function, and it does its job. Mm-hmm. And you can schedule them and do all kinds of things that you would normally do in like a console app or something like that.
Yeah, and it's got its own error logging and that type of thing. Plus, you can communicate with your own SQL server if you want to. If you got like an Azure Cloud SQL server with an error log table or something, you can do that too. So it's pretty slick. And if they've changed it to where you can use a real programming environment now, so it's going to make it a lot more popular, that's for sure.
So in the, just making sure I understand the mapping. So you're actually mapping device, because those are individually authenticated and pinned via this manual setup of the technician and whatever mapping they use.
Right.
Okay.
And this is what it looks like right here. So you go into, you pick your photon setup menu item. If there are any that need to be set up, then you've just got these buttons down here. And it says, okay, well, this one needs to be set up. It should be showing red on its little RGB LED that's on the photon. So you click that button, and then you get the setup over here. And then you can pick the particular winder that you're about to set up. And then you can tell where the starting spindle and ending spindle is, and it knows how many spindles each machine has, so you can't pick like too many spindles or whatever. You save that and communicates. There's an API call back directly to the Photon cloud into the Photon, and it goes into run mode and starts.
So prior to them getting out to the NEMA enclosures, was there, when the Photon part comes in, gets unboxed, does somebody then use their phone app to set up the Wi-Fi for the locale? Or does the installer do that and assign the Photon to a particular account and everything? Or is that separated from the installer's job, the person who's doing the wiring?
Yeah, they have, what's the direction? We're going to go with the product direction on that?
We're using the product, but you still have to use the phone app from Particle, and you enter the SSID and the password, and as soon as you do that, then it'll flash it with the code.
So you're going to have the installer do that? Or
yeah, the installer will do that. So he really has two apps he has to run. He has to run the Particle app to configure it to the network, and then he's got to use our app to configure it to the machine.
Yeah, I just wondered if there was extra logistics in somebody having to know something about the Photon cloud.
Yeah. It's I think it's pretty seamless. So I mean, that product functionality, once you give it the ID, then it says, okay, it gets this code, and it just downloads it and burns it.
So there's no registering with the IoT Hub at all. At that point, you're already registered. Just communicate.
You do have to register. And then you tell it that it's got an ID. So what happens in this piece in the Photon cloud that makes this connection is that you tell it which of your photons, because it knows which are yours, that you're going to send information over to the IoT Hub. And the IoT Hub then, once it sees that identification information, says, oh, okay, I know that device. So yeah, there is sort of a two-part piece to that.
You keep talking, I just need to get the mic batteries died.
This is weird.
So,
yeah, that's what, that would be even weird.
That'd be
weird. Just for pedagogical reasons, I'll ask the similar question I asked before about these devices being on. Are they on the internet of the business, or are they on something separate? And what you're thinking of this IoT device being on the internet in the company?
Yeah, they've got a separate network just for this, so it doesn't have any visibility to any of their other networks.
Back pocket.
Okay. Thank you. As far as the availability on the internet goes, I don't know. I mean, it's kind of the way these things work. If you want to get up to the cloud, there's no way. A couple of things there, I guess. All right. So even let's say somebody did manage to hack into one of these Photon devices, they can't do anything except mess with the data. All right, because these don't control the machines at all. They don't tell the controller anything to do. If they were able somehow to get into it, they could just change something about the data or the connectivity, and that would be the other part of the thing that makes it relatively secure, I think. Did that answer your question?
Yeah. It is always, right now in the industry, it's unclear what devices can do. For instance, if this Photon was hacked, could it participate as a bot in a denial of service attack of other industries?
So absolutely, it could be using the attack to attack someone else, but since it's on its own network, it won't attack anything it serves.
Won't attack any of the equipment you've got there running.
Right. And the other thing is you have to worry about safety. If it actually were part of the machine controls, you don't want to hurt people and things like that. And that's a big concern. But we're only doing monitoring, so we can't hurt anybody. We can't change the controls. We can't change the product. And so for a monitor solution, this was like a really secure, from the business perspective, way to do it.
If you were controlling something, would you have taken further precautions?
We definitely would have considered it, yeah. because you get a lot of value out of the way we did it. And the whole reason we chose Particle over other people's products was the cloud that comes with it, and over-the-air updates is so easy to reflash it and maintain the code. And it's like Steve can update the code if they want to change functionality, and like now they want to know how many RPMs do they have in a minute. He can update it from here or our office and not have to travel to Laurinburg. Things like that is invaluable.
Any diagnostic data you're getting out of it or anything, or is just literally just monitoring, right?
Right now it's
Yeah,
binary,
it's just
right?
monitoring.
Yeah, that's all we're getting.
Yeah, we do have to add, there's additional types of sensors that they have that we've got to add some code to handle. And some of them, it's like the absence of a signal means that it's working, and some of them, the presence of a signal means that it's working. So we have to change the setup process a little bit to account for all that. Yeah?
Do these photon devices, are they constantly connected to the internet? And what happens if their internet connection, etc., doesn't cache the data?
Yeah, that's something that we've talked about. These things don't have huge amounts of memory. But we've talked about having potentially some intermediate step that queues these things up and then sends the messages up and things like that. We haven't needed to take any action along those lines, but it's certainly something that we've considered. How would we do that?
Yeah, it's been surprising how stable Wi-Fi's been and how all the messages have been received. But yeah, we did consider, and for the first phase, we decided not to, and we decided to wait and see if we need it. And so far, we haven't needed it.
There's actually a new product that Microsoft's coming out, IoT Edge, which is designed for that scenario. Basically, having an edge device in your network that's local for your Wi-Fi, and then when you get connectivity to the internet, then you can pump the message and the data up.
I did IoT hubs and all that.
Yeah.
There's a lot of industrial IoT companies are building similar things. But I mean, from a business perspective, the data here isn't really real-time use, right? I mean, this is trending, like you said, in a given day or a shift or a week or whatever. Where do we have the most downtime, and then tracking that as a business process, even if they had like you said, you had a 3 or 4 hour gap. It's an annoyance, but as a business issue, it's not a big deal, right?
They want to be able to look at streaming analytics and see a heat map of the plant and see what's up and what's down and just be able to glance at it. In their break rooms, they have like a TV where they do a dashboard and they want to see stuff like that.
Just out of curiosity, did they actually know how to use it for anything?
Well, yeah, it's actually surprising. There's a company in Laurinburg, and they're all about data, and like all their managers, they all got their MBAs together. So they all have MBAs, they all like to analyze data, but to do that, they have to have the data, and so that's what this is all about.
I've just seen a lot of monitoring systems that end up as a pretty picture.
Yeah. So, this is a little different of a company. They have a different attitude, and with it being in textiles, they have to make the product cheaper. And
right, yeah, they got a real thin margin.
They pay their people like 30% more than the other manufacturers in the area. And so they're paying more, but they have to compete with cheaper labor forces, and so they have to do things like this to be more efficient.
Cool.
So just one more question here. So do you have someone who monitors ever so periodically to look at the actuals versus what you're getting from the cloud?
Yeah, I don't think that they haven't done that at this point.
They've been auditing it. At the beginning, they had people with clipboards writing down what it was so they could reconcile it with the cloud to make sure we weren't lying to them. And after a couple weeks of it, they just kind of believe the data now.
Yeah. They don't have a formal program for that. Yeah, and I mean that's the kind of thing. From my manufacturing background, it's kind of like inventory cycle counting, things like that. You want to go through and do that periodically, right? And then that tells you how often you need to do it and that sort of thing. So right now it's pretty informal.
Yeah, you don't want it too often so it becomes an irritant.
Right.
Well, the manpower involved starts to cut into that savings.
Yeah, exactly. Yeah, that's right. Yeah, you don't want to have to audit it, all right? So, yeah.
There's some
But you've got to have the data that tells you you don't need to. So
Right, yeah, you got to be able to take snapshots occasionally.
Yeah. So
Do they have any estimate on an ROI in terms of time?
Yeah, they their CIO loves numbers. He hasn't shared them with me yet, but I'm sure he's computed out to the nth degree on all the ROI. It's huge.
Well, yeah, I think
like
at one
weeks,
point,
months, any idea?
well, at one point, one thing that, as far as time frame, I'm not sure about. I know he did mention at one point the possibility of not adding a third shift just by more efficiently managing these spindles. So that's
So the problem before this solution was that there were idle spindles that could be running that weren't because they simply didn't know that there was this available spindle to run.
Right.
Well, it's like every manufacturer. They need to have data so that they know what their problems are, and they don't have real-time data or data at all to know. They want to make decisions like there's automatic change-out machines that can change the thread to put different products in. Is it worth that capital investment? Or is it best just to keep employees to change out inventory? Or at the end of a shift, can they load up the machines and then go home? And how far into the third shift will they run unintended and things like that?
And I know we talked about at your meeting predictive failure.
Yeah.
And are anticipating that coming from this system?
Yeah, I think that we're more excited about that than they are. But once I think that they see that you can make predictions, and because we have a stream of data that we wrote from a work order system, we know when the machine fails, and so we can have a stream of data that says this machine failed, it was this spindle, and this is what they did to fix it. And now we get the utilization data, we can use the utilization data, marry it to the stream of what broke, and then have it try to predict when it's going to break next, and then write a work order in the off shift to try to fix it.
Are they looking at it for a liability perspective, like this machine breaks all the time, so maybe they need to take the machine out of service, or they may need to rebuild it or something like that?
Yeah. They're more interested in utilization data, and then if we can get them extra value from the data, like predict when it's going to fail, then that's just like icing on the cake. That would just like thrill them and be amazing to them.
Are you guys using other sensors other than what you're getting from the PLCs? Like if somebody needed say they're doing extrusions and it's coming out at 850 degrees and it's too low, and you've been doing like a thermal pile or anything like that, or say there's a polymer being squeezed and it's colors off.
Yeah.
You need a color sensor.
Yeah, so like for this project, there's 3 different types of sensors. One's an optical sensor that works kind of like a mouse and it sees the thread moving, and then there's like a limit switch type sensor and the proximity sensor. So it really depends on the project, but this one has 3 relatively dumb sensors that are easy to interface with. And every project would have something else that you're interfacing with.
So it's different for every project.
Yeah.
Now, is any of this data, like looking at the processor, it has like crypto hash. Do you use any of that to send the data over a network?
You speak
No.
TLS up to the Photon Cloud natively, isn't it?
Right. Right. Exactly. Yeah. We don't do anything beyond that.
Just send it over as is.
Yeah. Right.
The cloud's all encrypted.
Yeah. It's TLS connection from the local op, so it's already encrypted.
Yeah, so there's no need to encrypt the data locally.
Right. My only other slide right now is just discussion. I think we're already.
So hardware-wise, what was the total cost per unit? I mean, it was like somewhere around 100 watts or plus or minus.
No, it was $15 for the breakout board for the photon. Call it $20 for the photon. $750 for each of the 2 opto isolators, and then beyond that, it was really just labor.
Yeah, one thing to consider is we took an agile approach. Everyone a lot of companies make the mistake, I think, where they design a PCB for the first iteration. We did a complete prototype using prototype boards, prototype everything. And so the price of the prototype is probably like $50 each. The real price is the extra labor it takes to install it, because now you have 3 boards you have to install.
Right.
And so our next iteration is a PCB board that's got the power supply built into it, and much easier to wire up to save time for the machine repair guys.
Yeah, but you got to prove the concept in a hurry.
Yeah.
And you got to production in a hurry.
Yeah, answer that question. How long did the whole thing take?
Boy, it was from the first discussion we had to the day we went to install, it was like 2 months, I guess.
Yeah, it was like 2 months, and we had parts waiting from China for like 4 months or 4 weeks. That's half the project. We ordered this early on.
Yeah, we did things like, we got sensors from Amazon for like $7, and Dan's going, how can they make these for $7? These are usually like $150, right? Well, it turned out that the switching sensitivity is like once every 2 seconds or something like that. So he got us up and running, but it almost took us down a path too. It's like, wait a minute, it's not keeping up. So you ran into things like that. But yeah, you have to kind of improvise along the way. We had to do a lot of that, and like this wooden piece here to simulate the environment and everything. There was a lot of that going on. So that was like nights and weekends messing with those. The cool thing is it was just so much fun, it was hard to stop messing with it.
And they paid you for it.
Awesome. And I got paid.
It's really 2 developers, him and Carolyn. Carolyn did the Angular JS part of it. And he did all the Azure IoT stuff and the hardware and the embedded code.
All right.
Yep. What was the experience like communicating the infrastructure / software side of it, the Azure piece? Because they probably understood the hardware, the photon board, but what's happening under the covers, the infrastructure as far as the cloud computing, as well as the software development cost. Because like you said, you're dealing with people with MBA, so they're looking at bottom line return on investment.
Right.
What was that experience like of hardware side, software side?
You want to talk to that?
Yeah, you please.
Well, I thought it was pretty good. Now, this is a long-term customer, so there's a real strong relationship that we already have with them. So on the plus side, when it gets to the black box side, they trust us. All right? Okay. So that was a lot of it, and we gave them pretty good estimates up front about how long it would take. It was broken out into line items, and we kept track of our time by line item too. And whenever management there wanted or felt like they wanted a technical explanation, we would give them as much as they felt like they needed to absorb. And which for some of those guys was kind of important, because they talk in like breakfast meetings with other executives and things like that, and they want to be able to describe this accurately, especially in case there's a CTO there or something like that. So I thought it went really smoothly myself, but a lot of that is because we just have such a good relationship with this company.
Did they just take the database data raw? I mean, they have their own analytics and reporting people, so you just handed them a schema and they took all
No. So at first, the goal is let's get a bunch of data. And we've written some basic reports, like how many stops do you have in the shift, and what's the utilization, things like that. But we really want to do more with streaming analytics to show them more real-time information, dashboard type things. But yeah, there's still like very basic reporting, and a lot of what they'll do is they'll export the data to Excel and then analyze it in Excel for the first phase.
So you're really writing a front end of this entire system to satisfy their reporting needs and all that, and that's going to be an ongoing software project?
Yeah, it's going to be ongoing.
You said they love numbers so much. I wondered if they had their
own
analysts.
Yeah, they do, but they also want to like noodle on some of their own reports before they have us do too much. They want to give us more.
So they're going to hack them up, mock them up, and then hand it back to you. We want it to look like this.
Yeah.
Right.
Okay, that makes sense.
Yeah, because everybody's got Excel, right? So if you can get the data out to them, and the next thing you know, people, engineers and managers just go nuts with Excel.
Yeah,
sometimes
an error in there.
Yeah. So, but yeah, and it's just beginning, and we're going to start a new phase, and so they're, you know, it's some pretty creative imaginations that we're working with. So it's really taking off.
So if we had more data, we're using Microsoft SQL Server for this, which is fine because in Azure, if you're less than 250 gigs, it's not expensive. But the problem is if you go over 250 gigs, then it becomes super expensive, and SQL Server would not have been a good option. But we chose SQL because the other part of the application was built in SQL, and Steve and Carolyn both are very good in SQL, but we would use something like Cosmos DB, a document-style database or something like that, if we had more than 250 gigs of data. Yes, Mike?
So I'm wondering, I heard you say you're sampling at 1 minute, and I'm wondering what the average runtime of a spindle is.
It varies by product. But it's going to be, from what we observed when we were there doing the installation, each one's going to run at least 10, 15 minutes is what I know.
So from a data standpoint and also from a diagnostic standpoint to tell you whether something's going wrong, if you had structured this so that it compresses time and only sends data on a transition, then you both compress the amount of data that you're transmitting because you couldn't possibly go to 15 minutes between sends. And also, if you've got something going wrong, you could see a sensor going hot, then cold, then hot, then cold. And if you send those transitions, you might be able to do some failure analysis on a machine that's broken, you know, where either the sensor's bad or the machine is spinning wrong, you know, or not spinning or not starting or whatever. So I think that compressing your data instead of doing a standard sample is going to give you
Actually, the reason we didn't compress the data like that was for the exact reason that you said we should do it. It was for the machine learning algorithms. I was thinking it'd be easier if we just had raw data that we could let the algorithms try to figure out the relationships. And
I would be interested in how, what the detent on tracking the start and stop times is, because I bet you get a lot more precision and information out of start and stop times, especially if you could get a cycle where you could see a spindle start and stop in sub-minute, something like on the order of a second. You could actually get your time base of starts and stops and the run length time of them down to a second time base, and then you could see something even more interesting in that data.
There's one other consideration, though, for what you're saying is, from a reliability standpoint, sending a constant stream of data or no data, instead of sending transitions. If you lose a transition, you lose an entire state. Whereas if you have a constant stream, you may lose a bit of the stream.
Well, they're TCP/IP, so you're session based. So you get an ACK that the packet got to its endpoint, right? Yeah. It's plus it's MQTT. I don't know whether there's something protocol wise on top of the TCP that tells you that the message got delivered to the broker, or to whether it fanned out to endpoints. But I think the chance of you with TCP/IP dropping the packet and it not getting resent and what have you is extremely low. You know, basically you're assuming a reliable network in this case. So,
I think to do basic
I would like to actually, I think there would be an interesting comparison to see how it operated the opposite way.
I think that if you're trying to do like data, what's the utilization of this department versus this department, it's easier to do those aggregations for the reporting from the raw data than just the transitional data. I think you have to do more, the reports would take longer to come up for some of the reports.
Okay.
Because I hyperanalyze. But the fact of the matter is they had a business problem, and 2 months later you put hardware and software in their hands to solve their business problem as they defined it, which is freaking fantastic.
It's pretty cool.
It was a hell of a fun project too. So.
Yeah, that was fun.
Yeah, that makes
If it wasn't as cool, it would have taken a little longer, right?
Yeah, that's right. That's right. Yeah. Maybe a lot longer. Yeah.
How long paid overtime involved in that one because you just can't away from it.
All right.
How long ago was this installed?
This was installed on April 28th.
Remember the date, huh?
I do.
Wow. I'm glad you asked him the question.
Yeah, that was a long day. I remember that.
You were saying, mentioned earlier about the spindle speeds, and using you use timer, I presume, right?
Mm-hmm.
Each one, and do you have, when you have to do that, do you write it in C, or are you using a lower level language to address individual timers?
Yeah, at this point we're not using the hardware timer. We're literally, the thing is just like an Arduino, it runs in a loop. And
Just doing a count?
Just doing a count. Mm-hmm. Yep.
Looking for a change of state.
Yeah, looking for changes of state within so many loops and that type of thing. And it's worked out really. It's surprisingly accurate, actually. That was one thing I was a little worried about, but it's been really close to a minute, really close. And the time from when the signal, so the photon sends the signal to the cloud, or the message to the cloud, and it's time-stamped. And so then by the time it gets to insert it into the SQL table, I don't think I've seen more than 3-4 seconds, and that would be unusual. It's usually like 2 seconds for the entire trip. So.
When a spindle empties, it has no thread on any longer, does it continue? I'm imagining some of these are spinning really fast. Do they have automatic brakes on them because they're not seeing a thread go by, or do they keep spinning for a minute, 5 minutes, until they really slow down and then the sensor would pick up?
Once that proc sensor determines that there's no activity anymore, it breaks it. Yeah, okay. It's not like real sudden, but yeah, it does. It does stop the machine. Yeah. And that's all in the PLC.
Is this like an ongoing trend where manufacturers are asking for this for more data?
Well, we sure hope so. we feel like there's a lot of potential there, and we enjoy doing it and have a lot of experience doing it. I think the answer is, given that Gartner analysis I showed early on, that it's going to be up to 270 billion from 70 billion by 2020, says that, yeah. And I think the challenge at this point is not so much microcontrollers and sensors are commodities already. It's what do you do with that information once you get it somewhere, right? And then how do you do that? And what's the best way to do that?
So yeah, manufacturing is one of the most important areas of IoT, and this project we did is really important to Particle 2. They're posting a case study and they're using it as a reference to Gartner, so that they look good to when they, like they're one of the gold companies that are recommended for IoT platforms, and they're using this as a reference, and they're also sending it to their marketing channels as well.
Did anybody ask if you could take a Raspberry Pi with a Raspberry Pi camera and OpenCV and look at an area of the floor and watch the spindles move? Did anybody ask whether it's possible for you to do that or thought about doing that?
Yeah, but no, we didn't really consider that.
I don't know whether it's possible or not. I know you can grab frames and then you could do analysis on the frames. Whether you could detect whether the spindle was moving or not, I don't know.
Yeah, people would stand in front of it.
Some kind of marker problem.
You might be able to just put something on the base. Is that the spindle right there?
Well, yeah, I was going to say that. Well, it's similar to that actually. So the thing that the thread is on, even could be monitored as far as that goes.
Yeah, maybe you could look at it from above. So
Yeah,
maybe so.
And that flash drive, it's just not.
Yeah,
just
I'm
not
a big fan of keeping it simple personally.
Yeah, right. Give me a microcontroller any day.
Yeah.
Never underestimate the power of the loop.
Yeah.
Is a photon running 24/7?
What's that?
Is a photon running 24/7?
Yes. Well, it's up. I mean, it's available. If they turn the machine completely off, which sometimes they do, then that shuts everything in the panel off, including the photon. But then when they turn it back on, it goes through that startup process and starts right back up.
Have you guys tried any over-the-air? You or somebody mentioned the ability to push updates through Wi-Fi down to these devices. Have you guys tried that yet in a production environment, and how'd it go?
Yeah, it's we did it in the test environment.
Dude, it's awesome.
Yeah.
Pushing code to the photon, just sitting there. I mean, I've had my desktop on my home network, and a photon on a phone or whatever, and just push code right to it. And it's slick. And the libraries and the programming and the IDE, and you just grab a library, throw it in there, right? I mean, for standard stuff, I mean, you can throw together something quick.
I've seen it used before, but I haven't used it myself. Is there any risk of like bricking it when you're pushing?
Just breaking the monitoring, you'll miss a minute or two of data.
Okay, but you wouldn't you couldn't brick the photon itself, where you wouldn't push another.
Oh yeah.
So I remember the story about the manufacturer of the door locks that pushed an update out in the last month, and all of a sudden all these door locks.
Yeah, that just happened. And here's the concern. You got all these over-the-air photons, and everybody trusts Photon
to keep them straight.
To keep all of them separate to different accounts and what have you. Now somebody comes in and hacks Photon corporate.
Yeah.
Okay.
Now they've taken over all the photons, and what they push is denial of service attacks on
everybody else.
The DNS for all of the major servicers for like Netflix and what have you. So I think that's the big problem, because now everybody's got their photon on a network that can be bridged to the internet.
Well, couldn't the IT though set up a firewall that limits what port it can
Yes, but then you don't have over-the-air programming.
So one thing, but you do because you have it going down that channel. I mean, the photon's not reachable from the photon cloud except when it makes connection and opens at the electric.
So here's what I would advocate, and this is what I'm going to be actually developing in the marketplace. But I would advocate that everybody have their own keys and their own secure channel to their own devices from their own control systems instead of going through Particle. When you're all going through Particle, if Particle gets hacked, you're all hacked.
I know, but it just bloody works so nice.
But it's like
you go to the phone, you program it up, and you push some codes. Good,
right? It's like you got the security in house. What's in the car?
About Particle, Mike reminded me this the other day. Their cloud service is all open source. If you don't want to use it on their servers, you can host it yourself.
I asked about that, and in their case, you could do over the air by hosting your own cloud server and going. Now, I don't know about their tool set. I had trouble working locally with their tool set, actually directly USB flashing the devices, and they had problems with that.
Really?
And what I had to do was go back to the over-the-air programming through the Particle site. And I wonder if you hosted your own cloud, whether you'd have full access to all the programming tools on their cloud so that you would avoid those local problems with programming Particle. But that's the solution right there is, I'm an industry, I want to protect it. Now, the problem with the commercial devices is Jeremy's got his stuff at home. He's going to be part of the denial of the service attack when they take over.
The Particle Cloud is inexpensive too, so we could host it ourselves, but it's going to cost us a lot more than $80 a month we're paying Particle.
I wonder if it comes down to it. The DigitalOcean, the cheapest DigitalOcean VM is $5 a month, right?
Well, maybe the hosting fee itself, but
it's the maintenance, the administrative overhead and everything else, right? Yeah, I mean, this is all about business analysis, security analysis. In this case, like you said, even if they got attacked, the worst thing they could do is monkey with your data. Now, if you're driving a chemical plant and you're controlling valves, I'm going with Mike's plant.
Yeah.
Please, as a neighbor, please go with Mike's plant. And other ways to completely secure the network. But yeah, the fundamental rule about security is you don't spend more on securing the data than the data is worth to you to begin with. And that's where you have to start making that kind of calculation.
Well, I came from a meetup where we were talking about all the devices, commercial devices that are going to be on the Internet of Things that aren't business, IoT. And they're going to be they're going to be botted by some nefarious guy, you know, around the world and used to take down the federal government or, you know, whatever your favorite thing to take down.
Yeah, you're putting a lot of,
You might particle for that.
but it's been going on for 20 years.
You have 2, 3.
The other big issue you have too is if everybody's doing their own cloud, but they're not religious about doing patches and things like that, you've got a super big problem.
Yeah, I mean, if you really want something that's secure, you got to roll your own solution. You got to make it obscure. You got to make it obtuse. It's the only real way to do security nowadays. And anything else is just. But I mean, I just want to control the lights in my bedroom. Have some fun. I mean, you know, I'm not trying to do anything big. So for me, you know, it's about my time, and I can spend my time screwing around with what serial ports, get the Arduino Studio to flash with, where I can put a chip in a board, do the connection to the Wi-Fi, and just start pushing code to it. I mean, for me, it's been a lot more, just a lot funner way to program and enjoy, you know, what I do for side projects, and that's for me what it's about. And you know, that's why I paid $20 a piece.
Hey, I want to remind everyone too that we're going to be giving prizes to people who post nice things on Instagram and Facebook. So hurry up and write some nice things about how awesome the meeting was.
By the way, Facebook Messenger, it's like Uber. It takes over and reads all the stuff off your phone and sends it to Facebook. They're talking about it now on the security point. So.
Yeah.
That's all I got.
All right. Thank you, Steve. I can't thank you enough for like getting a phone call at 3 and actually was an email. He calls me back. I didn't even reply to him, and he still got ready for this talk tonight. So much appreciated. All right, so we've got 2 Docent IoT kits that we're giving away, and if you guys were at our hackathon, these were really fun. And there's something you have to do to flash it. I can't remember what it is, but Patrick wrote it on the meetup site for our Docent meetup on what you have to do.
Flash your model before it online.
Yeah, because there's something wrong with the chip unless you flash it some way.
It's a bootloader, I think.
Is that what it is? Glenn, can you tell us 2 people who are our winners?
You want me to just pick 2?
Yeah, well, should we do a random number?
The second and the fifth.
There's only 5. What's that?
The second and the fifth.
All right, Robert White and Michael Gorman.
Yeah, sweet.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.